Welcome to the lecture on radians and degrees. And let's get started here. In order to apply the knowledge we have about functions from algebra and trigonometric functions, we need to write angles as real numbers, and that is in radians, not in degrees. By definition, in a circle, the angle that produces an arc length equal to the radius is called 1 radian. Consequently, the circumference is equivalent to an angle of 2 pi radians. And we know that from that the circumference equals 2 pi times the radius. If the radius, of course, is 1, then we come up with a circumference of 2 pi. And the radians are expressed in the same manner. So once around a circle would be 2 pi radians. And any kind of degree in between would be a fraction of that. As an example, for the arc length would be that we have a radius, let me make this lowercase r, then we have a radius of 3 centimeters and an arc length of 6 centimeters, and then the angle that would be subtended here is 6 divided by 3, which comes out to, let's see, 6 centimeters divided by 3 centimeters, which comes out to 2 radians. Okay. As we deal with radians, we're often interested in what is it in degrees. In fact, that's pretty much what we have to handle on. What is 45 degrees? What is 80 degrees? What is 140 degrees? And we're less familiar with to say what is pi over 4 degrees? What is 4 over 9 pi? I'm sorry, radians. What is 3/4 of pi? In fact, the 3 examples I just mentioned were equivalent to the degree measures, just we're not familiar with that. I'll mention that in a little while. So we have to figure out what are the conversions between degrees and radians. Well, since there are 360 degrees in the circle, and that is equivalent to 2 pi radians, the conversion would be 2 pi over 360, or pi over 180. And in most trigonometry books, you find the second one. You see it's a little bit easier. I personally would use this one here. That's what I'm familiar with, but let's stick to this one that you find in the trigonometry books. Pi over 180, or if we go the other way around, it would be 180 over pi. Here, just on the side, this is what I always like to use. A quick conversion can be achieved by multiplying, respectively, dividing by 50 or 60, and that is because when you do 360 divided by 2 pi, you come up with 57.3, which is either roughly 60 or 50, because it's easier to multiply or divide by 50, regardless of if you spell multiply correctly. All right, let's do some examples. 45 degrees. And we do this one here in just a moment. Let me do the quick estimate. 45 degrees, roughly divided by 50, so I come up with 0.9 radians. The correct one would be 45 times 2 pi divided by 360, and it's granted that you can do that on your calculator, so I don't need to show you that, so I just do it on the side here, that exact calculation, and I come up with 0.785 radians. Notice my estimate is a little bit off, but it's definitely in the neighborhood. As I said, this is just a quick one for me to do. 450 degrees. My estimate would be roughly divided by 50, so I come out with 9 radians. In the meantime, I kind of know that it should be 7.85, or let me make it 8 radians. I round it down. I do that on the calculator, so I'm going to do 450 times pi divided by 180, and I come up with, of course, 7.85 radians. Notice that here I use this conversion and here I use this conversion. They're, of course, completely equivalent. The 2 is being canceled here, and this is the quicker one, pi over 180. So from now on, let's just use this one. Pi over 6 to determine what it is in degrees. Pi over 6, top of my head, it is 3.14 divided by 6, which is roughly 0.5, and that is rounded down, so let me use the larger of the 2 quick conversions, 60 or 50. So 0.5 times 60 will come out to roughly 30 degrees. Let's see what we come up with. So what we would do is the following. Let's see, pi over 6 I'm going to do. This time around it's going to be times 180 degrees. Divide by pi equals. So again, I'm going to do that on the side here. Actually, we can do this in our head. The pi here cancels with this pi, and then it's going to be divided by 6 multiplied by 180. We come up with 30 degrees. I'm right on with my estimate, but I kind of knew that. We have to become familiar with that certain fractions of pi. We just have to memorize them. Pi over 6 is such a fraction. Notice that pi is equivalent to 180 degrees. That means pi over 6 needs to be equivalent to 30 degrees. Pi over 4 needs to be equivalent to 45 degrees. I kind of skipped that here. I guess I should have put that in here as I did that. As you look at these numbers here, we have 45 times 2 is 90 divided by 360, which is 1/4. So we come up with pi over 4. Pi over 4 equals. So here what we get is, oops, didn't need to do that. That we're familiar with that since 180 is pi, then pi over 4 needs to be 45 degrees. Okay, let's do a few more. 4 pi thirds. I can just look at it and say, well, this is 1 and another third pi, so it's 180 degrees plus another 60, so we will come up with 240 degrees. And the proper way to do this is as follows. So we have 4 pi thirds times 180 divided by pi. There will be, the pi's will cancel, and then we have 180 divided by 3 is 60 times 4 is, of course, 240 degrees. Okay, sine pi over 6. Well, pi over 6 is the same as 180 over 6, so we're going to have 30 degrees. Sine of 30 degrees, we have that memorized as 0.5. 4 times sine pi over 6 will be sine of, well, this is 1 pi and another pi over 6. So 1 pi is 180 and pi over 6 is 30. So we have 210 degrees. 210 degrees, sine of 210 degrees times 4, the amplitude in the front. And so what we have is the reference angle would be 30 degrees. We know that is 0.5. We're in the third quadrant, so it's a negative 0.5. So we come up with a negative 2 for this one. Okay. One more. It is important to become familiar with radian measure and to memorize special angles. Those are the same special angles as 0, 30, 45, 60, and 90 degrees. So we will have to memorize 0, pi over 6, pi over 4, pi over 3, and pi over 2. And of course pi for 180 and 2 pi for 360. And this is from me. However, it is likely that even after a long time of using radians, as we're calculating radians, we always convert to degrees, or most of the time we convert to degrees at the same time because that's what we're familiar with. So when we say 2/3 pi, well, we're kind of familiar with it, but it sounds better to us if we just say 120 degrees, even though we calculate 2/3 pi, but we still have in the back of our minds that that is 120 degrees because we're more familiar with it. Okay, we need to memorize. This is what we already have memorized. Again, if this is a little bit off the screen here, just scroll down on the side. So we have already this here memorized, the sine, the cosine, the tangent for all of these values, the exact values, the approximated values that we calculated. And now we have memorized the angles, and now in radians. So theta for 30 degrees comes out to pi over 6. 45 degrees, pi over 4. I think I will scroll down a little bit myself here. There we go. And pi over 3 and pi over 2 for 90 degrees. So memorize those as well. And that was the lecture on radians and degrees.